Section 4.3, Solving Applications Using Systems of Equations. So our goal in 4.3 is to write two equations that look like exactly what we've worked with in 4.1. So we need to translate sentences, maybe know a formula once in a while, and get two equations. So be careful on how you do this. Again, guessing is not credited. We're looking to see if you can make two equations that come from the word problem and solve them accordingly. So the first thing I want you to do is read it a couple of times, and then try and figure out what the question is asking. So as of April 2013, the Twilight Saga Breaking Dawn Part 1 and the Twilight Saga Breaking Dawn Part 2 grossed a combined total of 1,542 million. If Part 2 grossed 818 million, more than Part 1, how much did each movie gross? So I always tell my students, look at what the question is asking, and that's what your variables are going to represent. So we're going to say x equals the amount grossed by Part 1, and we'll let y equals the amount grossed at Part 2, because again, that's what it's asking. How much did each movie gross? So x is going to be the amount grossed by Part 1, and y will be the amount grossed by Part 2. So you do need to label your variables. You can't just start off by writing equations. Make sure you tell me what your variables are representing. So now let's try and translate each sentence. Again, get very picky and just pick the piece that you need. We know they have a combined total of 1,542 million. A combined total. Total means to add, so we're going to add x plus y. So my first equation is going to be x plus y equaling 1,542. So there's always one equation that's going to be a little bit easier than the others. That was your easier one. Now let's look at the one that we have to translate more of it. If Part 2 grossed 118 million more than Part 1, how much did each movie gross? Well, we already got that piece. So how do we write if Part 2? Which variable represents Part 2? Well, y represent Part 2. Gross, that's your equal sign. 118 million more than. So make sure you understand more than, the order flips. So Part 1 goes first, and then more than that, 118. So x plus 118 would be the second equation. If you wanted to do substitution, you would go ahead and write y equaling x plus 118. If you wanted to do the addition method, you would need to subtract over the x. And then those would probably cancel pretty easily. So you get to decide if you want to do substitution, leave it as is, or if you want to do addition method, which you need to subtract over the x. So I'm going to let you solve this, and I'm going to give you the answers. So the amount grossed should have been, from Part 1, 712 million, and for Part 2, 830 million. So Part 1 grossed 712 million, and Part 2 grossed 830 million. So again, I want you to write your answers in words. I want you to understand what you found and be able to express the answer in a word format. So hopefully you can solve that one. If not, come see me or send me an email and we can get together via Zoom or face-to-face if we're back on campus, or any of those types of things. Math Resource Center is a great place to go to as well. Number 2, the average salary for a post-secondary math teacher is $37,330, less than that of a mathematician in the industry. Together, the average salaries total $161,430. Find each average annual salary. So again, be picky. Pick out what, first of all, they're asking for. They're asking for the average annual salary. So we'll let x equal the annual salary of, and let's do the math teacher. It doesn't matter. You can decide which one you want. That's why you have to label it. And y is going to be the annual salary of the mathematician in the industry. Okay, so now let's try and find the easier equation. The average salary for a post-secondary math teacher is that less. That seems a little bit more challenging. what's the next one? Together, the average salaries total 161,430. So again, total means to add. So we're just going to have x plus y equaling 161,430. So now let's go back to that first sentence. The average salary of the post-secondary math teacher. Which variable represented the math teacher was x. Is the equal sign. 37,330 less than that of the mathematician. So just like more than, we flip the order, less than has to flip the order, but we're going to subtract. So what was the mathematician's salary? That was y. And we're going to subtract off 37,330. So again, if you want to do substitution, you could leave it as is. X equaling y minus 37,330. If you wanted to do the addition method, you would subtract over the y and go from there. So I'm going to let you try that one on your own, and I'm not going to give you the answers. You have the correct setup. Oh, I guess I will give you the answers. So the salary of the math teacher, salary of math teacher turned out to be $62,050, and the salary of the mathematician was $99,380, and these are dollars, so use dollar signs. Alright, so we'll work number 3 out completely. This does have decimals, so you might want to have a calculator with you. So first read it. A broker sells a combined total of 40 shares of 2 different stocks. The first stock sold for $12.25 per share, and the second stock sold for $15.75 per share. If the total sale was $5.39, how many shares of each stock was sold? So again, look at what the what the question is asking. How many shares of each stock? So we know, let's let x equal the number of shares in stock 1, and y is going to equal the number of shares in stock 2. So again, the easier equation is the total sale was $539. How many of each stock were sold? I'm sorry. A broker sells a combined total of 40 shares. So which one is which? This one says the total shares of 40, and this one says the total sale was 539. So watch what happens. This one is the amount of stocks. This is the cost or the money that's coming back from them. So you got to be very careful on which one you use as just x plus y. So the first equation is just going to be x plus y equaling 4 shares. So x is going to be the stock 1, y will be the shares in stock 2. Add them together, we get 40 shares. Now the first stock sold for $12.25 per share. So $12.25 times x. The second one sold for $15.75 per share, so times y, and the total sales were $539. So if you like that equation, you can put it over there. Some students like to get rid of decimals because they don't really want to work with decimals. If you want to get rid of decimals, you would multiply by 100. The numbers get pretty large, but you can still work with it. If you multiply by 100, I get 1225x plus 1575xy equaling 53900. So you could do substitution because the first equation, either of those have a coefficient of 1. I'm going to do the addition method, and I'm just going to multiply the first equation all by negative 1225. So if I do so, the first equation becomes negative 1225x minus 1225y equals, and then when I multiply the last, make sure you also multiply by the negative, you're going to end up with negative 49,000. So then the second equation still stays the same, which is 1225x plus 1575y equaling 53900. So we're going to add those two equations together, and our x's are going to disappear. What's going to happen to our y's? So we're going to have a negative 1,225 plus 1,575. You're going to end up with 350y, equaling, if we have negative 49,000, and we're going to add 53,900, you're going to get 4,900. And if we divide by 350, we're going to get y equaling 14. Yay! It came out to a nice integer value. So that means we had 14 shares of stock 2. So how do we find stock 1? Well, we can take the first equation and plug in y being 14. So x plus 14 equals 40. So if I do 40 minus 14, I know that x is going to equal 26. So again, you want to write your answer in words. We had 26 shares of stock 1, and we had 14 shares of stock 2. Again, you could keep decimals and work with them. I got rid of them, so my numbers got a little bit larger, but I still was able to solve it. All right, a few more word problems. Number 4. Your grandmother needs your help. She has $50,000 to invest. Part of this money is to be invested in non-insured bonds, paying 15% annual interest. The rest of this money is to be invested in a government-insured certificate of deposit, paying 7% annual interest. She told you that she requires a total of $6,000 per year in extra income from these investments. How much money should be placed in each investment? So again, get picky and just find out what is the question asking. It's asking how much money should be placed in each investment. So let's let x equal the amount invested, and we'll put this one in the non-insured. And y is going to be the amount invested in, and this one's going to be the insured. So the non, and we have the insured. All right, so what would be our first equation? That's kind of nice. She has $50,000 to invest. So the first equation is just going to be x plus y equals 50,000. Now how do we get the second equation? We get 15% of the non-insured, and we get 7% back from the insured, and we know that we need $6,000. So 15% of x, 7% of y needs to equal 6,000. So 15% of x plus 7%, make sure you move the decimal, of y equals 6,000. So I moved the decimal twice, got 0.15. Moving the decimal twice here, I get 0.07. Again, if you want to work with decimals, you can. I like to get rid of decimals because I think it's easier to work with. So I'm going to multiply everything by 100. So I'm going to get 15x, multiply this by 100, I get plus 7y. Multiply this by 100, I get 60000, so I get 60,000. So now you can decide if you want to do the addition method or substitution. I'll go ahead and just do the addition method, and I'm going to get rid of the y's by multiplying by -7, because that's going to cancel when I add. So I'm just going to write this one below. -7 times x is -7x, -7 times y is -7y, and -7 times 50,000 is -350,000. And we're going to add those together. So 15 minus 7 just gives me an 8x. The y's cancel, and 60,000, right? 600. What am I at? Yeah, 60,000. Maybe I did that wrong. So 60,000. So something's not quite right. Maybe I had... Well, maybe it is. Yeah, so 600,000 should have been it. So 600,000 minus 350,000 would give you 250,000. So I think I left off a 0 up here. My bad. So 8x equals 250000. And divide that by 8. And we end up with x equaling 31,250. Sorry about that. When I multiplied by 100 on the 6,000, I should have had 1, 2, 3, 4, 5 zeros, 1, 2, 3, 4, 5 zeros, and I only had 4 at the time. So my bad. Hopefully that didn't confuse you too much. So now x is 31,250. We can plug it back into the first to find the y. So 31,250 plus y is going to equal 50,000. So then I just take 50,000 and subtract 31,250. And that's going to give me what y is. So I'm going to just subtract this over to the other side. And y is going to equal 18,750. So what does this mean? This means she needs to invest 31,250 in the non-insured, and she needs to invest 18,750 into the insured. So then non-insured, we're going to put non-insured. She needs to invest 31,250. She needs in the insured, she needs to invest 18,750 for the non-insured and for the insured. Alright, so number 5 you're going to see quite often, so I want to make sure you can do it. I'll do the setup and I'm going to let you solve it. But this is the one that I always call the bucket method, because I like to put things in buckets when it's talking about this mixture and adding another mixture. So number 5 says how many milliliters of a 5% hydrochloric acid mixture and a 20% hydrochloric acid mixture must be mixed to combined to get 10 milliliters of a 12.5 hydrochloric acid mixture. So what are we trying to do? Well, let's draw some buckets. And again, if you do it this way, again, don't memorize a problem, but understand the setup, you should be good on these buckets. So let's think about what we know. We know we want to combine to get 10 milliliters. So we want to take this one, combine it to this one to get 10. So this one needs to be a 10. Now that can move around sometimes. So we don't know x and we don't know y. So my first equation is going to be x plus y equaling 10. So my first equation will be x plus y equaling 10. Well, what are x and y representing? X is going to equal, we're looking for the amount. So x is the amount at 5%. And y is going to be the amount at 20%. Again, this number moves around, so you might have x here, 10 here, and y over here. So just don't try and memorize this problem because the variable does move around. So what would be the next equation? Well, we know that we have to do the percent times x plus the percent times y, and that should equal the percent times 10. So the percent for the first mixture is 5%, so that's going to be 0.05. For the second mixture is 0.20. And for the last mixture, it's 12.5. So move it twice, I get 0.125 to make it into a decimal. So my second equation is where I take my percents times x, percent times y, equals the percent times 10. A lot of students forget to multiply that last percent times the amount. So we have 0.05 times x plus 0.20 times y, and 10 times 0.125 is 1.25. Again, if you like decimals, you can put it over there. I'm going to go ahead and multiply by 100 to get rid of decimals. When I do so, I get 5x plus 20y equaling 125. So if you keep drawing these buckets, putting the x and y and the number where they belong, you should be able to get to the right answer. So you can do substitution if you want, or you can do the addition method. I'll give you the answers. The amount at 5% is actually 5 milliliters at 5%, and we get 5 milliliters at 20%. It normally does not work that way. It's not just half. So this one just turned out that it was just 5 and 5. But I promise you the other ones do not work out like that. So make sure that you're doing those problems setting it up by looking at your buckets. All right, last one. A boat travels 36 miles upstream in 3 hours. Going downstream, it can travel 48 miles in the same amount of time. Find the speed of the current and the speed of the boat in still water. All right, so we have to have a formula here. And I always ask my students, how are distance, rate, and time all related? Well, distance, rate, and time says distance equals rate times time. We're going to put distance over here, and it's going to equal the rate times the time. And we have an upstream, and we have a downstream. So the easiest thing to put in here is the time. Upstream, it takes 3 hours. And going downstream, and it can travel 48 miles, but what? In the same amount of time. So it's 3 also. Another thing that's nice to put in is the distance. We had 36 miles upstream, so I'm just following this is upstream, and we had 48 miles downstream, so 48 miles downstream. The only problem is the rate. We don't know the rate. We don't know the rate of either of them. What do I mean by that? Well, you have a speed of the boat and you have the speed of the current. You have two things, because if you're in a river and you're in a boat, the river carries you downstream if your motor is turned off. So this is something you definitely need to know. The rate is going to equal the rate of the boat plus or minus the rate of the current. So you're always going to have the boat plus or minus the current. So which one do we know? Neither of them, because it says find the speed of the current and the speed of the boat. So you better tell me which one you're representing. I'm going to say X is going to be the speed of the boat and Y is going to be the speed of the current. So we have our X and our Y. So think about it. Going upstream, is the current going to help you? Do you add it? Or does the current slow you down? It's going to slow you down because of the friction. So you're going to have X minus Y for upstream. The rate of the boat minus the rate of the current. Then, what about downstream? Downstream is going to help you go faster. So it's going to be X plus Y. So now we're going to just go ahead and do the rate times the time equals the distance for upstream. And then if you read it one more time, what does this say? It says a boat travels 36 miles upstream in 3 hours. Going downstream, it travels 48 miles in the same amount of time. Find the speed of the current and find the speed of the boat. So there's my boat, there's my current. Why do I have to put the boat first? Because the boat better go faster than the current. If it's airplane, the airplane better go before the wind speed. So make sure you put that in the right order. So X minus Y times 3 equals 36, and X plus Y times 3 is going to equal 48. Now we normally don't see the 3 at the back, but we can flip it to the front if you don't like it, or you can just distribute. So my first equation is going to look like 3x minus 3y equaling 36, and my second equation is going to look like 3x plus 3y equaling 48. So now you can see that it's set up for you in addition method. So personally, I see that the y's already cancel. I'll go ahead and add. So I get 6x, the y's go away, and 48 plus 36 is going to be 84. And then all I got to do is divide by 6, and that means x is going to equal 14. So what does that mean? That the boat is 14 miles per hour. But it also asked for the rate of the current. Well, how do we find it? Plug the 14 back into either one of those. So I'm going to let you finish that off, and you should get x equaling 2. So the rate of the current is 2 miles per hour. So make sure you can plug the 14 back in and get an answer of 2.